My dear students, I welcome all of you for today's session. And today's session is on mathematical analysis of non-recursive algorithms. So before stating what you are going to study in this session, okay, let me think. Assume I have given a problem statement to you and I've asked you to design a solution to come up with a solution for this particular problem statement. So what everyone will do, everyone will read the problem statement, analyze that problem statement, and you will come to know what actually you need to solve and how to solve. And now everyone have their own solution in their mind. So each of them solution may be based on different strategies. Okay. So now what you will do, you will represent your solution which is in your mind in the form of an algorithm. And let assume your solution is a non-recursive algorithm. Got it? So now everyone have designed a non-recursive solution. Now I need to tell whose algorithm is the best. I mean to say I mean everyone should be able to analyze the efficiency of the algorithm. Got it? Clear? So in order to analyze the efficiency of each of them's algorithm, what procedure I should follow? And let me tell you, right? Analysis means either space efficiency or time efficiency. Got it? So I won't concentrate much on space efficiency because memory has become cheap. I will give a stress more concentration on time efficiency. And while discussing time efficiency, I said we are not going to deal with real time. We are going to deal with a metric which is an independent. And that metric, I said, either a step count or an operation count. And we are not dealing with the step count also because few steps we can neglect. Okay. And I said in previous session difference between step count and operation. Right? Or what is an operation count? What is the operation, basic operation in your algorithm? I mean, what is an operation count? The operation count gives the count of the most frequently executing operation in your algorithm, and that operation we call basic operation. Got it? So now all of you have come up with your solutions, right? That is your algorithm. So now what you need to identify? You need to identify the basic operation in your algorithm. Then you need to tell me what is the basic operation count of your algorithm. Now, the one whose basic operation count is least, less, we call that solution is the best in that context. Got it? So these things we are going to study means given a solution that is a non-recursive algorithm for the problem what I have asked you. Okay, we need to determine basic operation count, and based on the basic operation count, we are going to tell to which efficiency class, either logarithmic, linear, n-log n, quadratic, cubic, factorial, exponential, your solution belongs. Okay, this is analysis. Analysis, I repeat, analysis means determining to which efficiency class your algorithm belongs. Okay, so efficiency classes we have discussed: linear, logarithmic, n-log n, quadratic, cubic, factorial, exponential. Got it? So now we'll look at agenda of this session. So first we'll have a look at general plan. General plan means what I said, you are given a solution, right? Your solution is a non-recursive algorithm. So what are the procedures? What are the steps I need to follow? Okay, to determine to which efficiency class your algorithm belongs to. Okay, so in general plan, we are going to discuss about the steps we need to follow. Got it? We are going to discuss about the procedure we need to follow. to determine the efficiency class to which our solution, that is our non-recursive algorithm, belongs to. Got it? So next, I need to tell what is about basic operation. Basic operation. I'm going to. We have already discussed basic operation is the most time-consuming, most frequently executing operation in an algorithm. Got it? So means when you design a solution, you need to identify in your solution what is that basic operation. For example, okay, let me say the problem is to determine the sum of all the elements in an array. Got it? So now in this case, what is that basic operation? It's nothing but addition. Got it? Let me take one more example. To determine the largest element in an array. So now what you will do, you will, in this case, what you will do, you will assume first element to be large. Then what you will do, you are going to compare this assumed large element with all the subsequent elements in an array. So whenever you're going to find any other element in an array to be large, your assumed large will get overwritten with this new larger one. Got it? So in this case, what we found, the main operation is nothing but comparison. Got it? So based on for each solution, it is assigned its own basic operation, and we need to identify that basic operation. I repeat, in case of determining the sum of all the elements in an array, the basic operation is addition, while in problem determining the largest element in an array, the basic operation is what? Comparison. Okay. So next, we need to determine best case, average case, worst case. Means sometime my solution for given input, my solution may exit very faster, and in some case, okay, my solution for some other input, my solution may take more time. Okay, and for some other input, my solution may take the time between some lower and upper bound. That we call an average case. Let me give you an example. Okay, suppose let me say linear search. Assume the problem is a linear search. Okay, assume the problem is a linear search. Okay, now array contains some n elements. Now the key element I need to search, okay, assume is the first element in an array. Got it? Key element I need to search is the first element in an array. Got it? So in that case, what happens in the first comparison itself? Okay, I mean to say when I compare the key with the first element of an array, match occurs. So no need to proceed for further comparison. Means the best case, this we call best case, means in one comparison itself, I can conclude key element found. Okay, suppose let me say the key element I need to search in an array is the mid one. Okay, mid one, which is at index n by 2. In that case, what I need, what I will do, I will compare the key, the first element, second element, third, finally at the n by 2 index. So at n by 2 index, the key element matches, and I'll exit execution saying key found. In this case, I took n by 2 comparisons. Okay, now let me say the key element what I need to search, maybe the last element of key element doesn't exist. In that case, what happens? I need to compare key with starting from the first element to throughout the array until I will compare with the last element. So if the key element is last, match occurs. If the key element doesn't exist, I've done all n comparisons stating key element doesn't exist. Got it? So in worst case, I need to do all n comparisons. So I mean to say for some solutions, okay, the basic operation count does not only depend on the size, but also apart from the size, it depends on some other parameters. Got it? If the running time of an algorithm depends on other parameters apart from the size also, in this size means n number of elements in an array. Got it? I need to determine best case, average case, worst case. And finally, we will have a look at some exercise problems. So now coming to general plan. Okay, coming to general plan. Okay, now everyone have designed your solution. Okay, there's something but non-recursive algorithm. Now, what is the first step? It's very simple. Listen cautiously. Okay, you can make use of apply this plan to analyze efficiency. Okay, what is first step means? You need to identify in your algorithm what is the parameter that acts as the size of the problem. For example, let me say in case of linear search, in case of bubble sort, selection sort, quick sort, mass sort, deep sort. Okay, I'm dealing with a one-dimensional array, right? So in one-dimensional array, the number of elements in an array acts as input size. Got it? So in case of matrix, there are two things: the number of rows, number of columns. Means there are two parameters in case of matrix that acts as a size. They are nothing but m and n. We call order of matrix. Okay. The first and foremost thing what you need to do in your algorithm, you need to identify, okay, the parameter or the parameters that acts as size. Usually it will be n in case of one-dimensional array. In case of matrices, it's an order of a matrix. That's nothing but number of rows and number of columns. The second thing, you need to identify the algorithm's basic operation. Okay, you need to identify algorithm's basic operation. I said some examples for basic operation, right? So you're clear with basic operation. No, what I said just now, I discussed my running time. Okay, running time of my solution. In some cases, for example, linear search. The running time of linear search, okay, in an array, just was not only depending on number of elements in an array, right? The running time, or what I can say, the basic of execution of basic operation, that is comparison in linear search. Okay, the number of times the comparison executes in linear search was not only depending on number of elements in an array, but also it was depending on the key element I need to search. Means, I mean, the execution of basic operation not only depends on the size, but also depends on some other parameters. Got it? Like key in linear search. In this case, I need to determine best case, average case, worst case. I said, right, in case of linear search, a key element is the first element in an array. Within one comparison, I can conclude key found. That's the best case. Okay, in best case of linear searches, basic operation count is 1. If the key element is the mid, that is at index n by 2, I need to perform n by 2 comparisons to conclude key element exists. So in average case of linear search, basic operation count is n by 2. Suppose key element is the last element in an array, or key element doesn't exist in an array. Okay, in that case, I need to compare key with all the elements in an array to conclude whether key is the last element or key does not exist. So in that worst case, the number of number of times comparison executes is n. So clear. This is clear about the third step. I repeat again. First thing, the first step is that you need to identify in your algorithm what are the parameters that acts as size. In case of one-dimensional array, n acts as the size. In case of matrices, m and n acts as size. Got it? So second step is that you need to identify algorithm's basic operation. I mean, in case of addition, sum of all the array elements, addition acts as the basic operation, right? In case of computing the largest element in an array, comparison acts as the basic operation. So third step, very clear. Just I repeated again and again, right? Now coming to fourth step. Now, you have identified basic operation. You have identified whether the execution of basic operation depends not only on size but also on other parameters. Now, what you need to do, you have come to know how many times the basic operation is going to execute. Okay, for that we need to set up some summation. Okay, so we need to set up a summation for the number of times the algorithm's basic operation is going to execute. Well, let us look at that through an example. Okay, the first step is that we need to set up a summation for the number of times the algorithm's basic operation is going to execute. Fifth step says that once we have set up a summation, we need to solve that summation. Okay, and solving that summation gives you exact basic operation count. Got it? You need to solve the summation using your mathematical induction. Okay, which you have studied in your discrete mathematical structures. Once you solve that summation, you will get exact basic operation count. Once you have exact basic operation count, okay, that count may be, you need to think to what type of function that it belongs, whether it's a logarithmic, linear, n log n, quadratic, cubic, exponential, factorial. Then you can represent that in terms of efficiency class, or to be more precise, an order of growth. I mean, you need to tell whether the basic operation count is, in this case, logarithmic, cubic, quadratic, exponential, and so on and so. Now, let will have a look at some exercise problems. Okay. Have a look at the slide. What is this first problem statement? Design an algorithm for finding the value of the largest element in a list of n numbers. Analyze the efficiency of this algorithm. Okay. So first thing, what what you need to know, you got what is the objective in this case? You are given an array of n elements, and this array you need to identify which is the largest element. Yeah. So what is an input? An array with n elements. What is an output? The largest element in this array. So now, how you will, everyone will come up with a solution. Okay, let me tell you the solution. It's a straightforward solution. So first, what we'll do? Solution that, let me assume the first element to be the large. That's what in this first statement, max val equals a of 0 means I'm assuming the first element, that is at index 0, to be the large and assigning it to a variable max val. Okay, so now assuming the first element to be the large doesn't conclude that first element is the large. Now I need to compare this assumed large with the subsequent elements in an array. Got it? Until this assumed large is compared with the large element. So in any comparison, if I find assumed large to be lesser than the ith element being compared, I mean to say, in any comparison I find ith element to be the larger than the max assumed large. Okay, then ith element will become the largest at that time, at that particular point. So what I mean to say, whenever I compare ith element with the assumed large, and if I found ith element to be the large, then I need to overwrite assumed large. I mean, I need to overwrite max val with the ith element. So this process I need to repeat until assume large, which varies over each iteration. Which may vary over each iteration. Okay. Until this, I mean to say, I need to compare this assumed large starting from second through the last element. And finally, I'll come with the largest element. At the last iteration, we'll have the largest element to be stored in the variable maxval. Okay, then I need to return this. Got it. This is solution. Now I've designed a solution. Now let me see how to analyze. Okay, to analyze. Okay, now let me come to general plan. What is the now? Look here. Look at the first two steps. First step, what is this? I need to identify the parameter that acts as size. Second step, I need to identify basic operation. I will come back. So in this solution, what is the parameter that acts as size? It's a one-dimensional array, means it's very clear. N is the size. First step is clear. I've identified the size of this problem, that is N. So second operation step says I need to identify basic operation. So what is basic operation in this case? Basic operation, I said, the most frequently executing operation. And I can see, okay, comparison is the most frequently executing operation. That is, if A of I greater than max y. That's the basic operation. That is, basic operation in this case is comparison. So first two steps are clear, right? First step, N is the size of the problem. Second step, comparison is the basic operation. So now the third step is that now whether this comparison, okay, executes whether this execution of this comparison depends other than N, depends on any parameters other than N? No. Okay, here the comparison should be done N minus 1 times. I mean to say, one, I assume first element to be the large. Got it? Then what I'll do is assume large, I'll compare the second element for the first time, third element for the second time, fourth element for the third time, finally nth element for the N minus 1 times. Were clear? Got it? So I mean for each of the I, range of i's from 1 to N minus 1, I will make the comparison. So got it? So means the execution of comparison depends only on N. Execution of comparison depends only on N. So here we don't have any best case, worst case, average case. Just we have a basic operation count. Okay. So clear. Now we need basic operations comparison. I need to set a summation for this basic operation. It's very clear, right? Summation, we know I equals 1 to N minus 1. 1 we can call, because one time comparison is going to exist for each I. So clear. So this is the same thing what I had done. First step, N is the size. Second step, comparison is the basic operation. Third step, what I say, execution of comparison depends only on size. It does not depend on any other property. So we need not have to investigate worst case, average case, and best case. Just we need to determine basic operation count. So setting summation, right? So summation, I think you need to know, very important is that you need to remember your discrete mathematical structures. Okay, and that especially mathematical induction and recurrence relation. If you have forgotten, I request you to go through your discrete mathematical structures. There you again recapture mathematical inductions, recapture recurrence relations. Recurrence relation I'll discuss in next session while discussing the analysis of recursive algorithm. Okay, now let me look at this session. Okay, summation. What is C? I have written C of n means here comparison, basic operation count for comparison. Okay, a C of n is a function that gives a number of times basic operation that is comparison is going to execute. I repeat, C of n is a function. Okay, and this function is going to give us number of times my basic operation. In this case, comparison is going to execute. Okay, just now come, I will look at the algorithm. Okay, so comparison, just look here, comparison, that is A of I greater than maxval is going to execute for each of the I value starting from 1 to n minus 1 times. For each of the I value 1 to n minus 1, how many times comparison? 1 times. So this is how we are going to represent using summation. Summation symbol. Okay. That's summation symbol I equals 1 to n minus 1, 1. So now, in mathematical induction, solving this, I'm adding 1 how many times? N minus 1 times. So what is C of n? It's nothing but n minus 1. Clear? So I think you're clear with analysis of non-recursive algorithm. Well, and now just now it is said about the basic operation. We found n minus 1. Now I need to tell which efficiency class it is, right? So which efficiency class? So what is n minus 1? What type of function is that? It's a linear. It's a linear. And we know it's a linear. So I just remember asymptotic notations. Big O, big omega, big theta. Big O, what I said, it's a lower bound. Okay, minimum number of times basic operation should execute. Big omega, it's an upper bound. Means maximum number of times basic operation is going to execute. And big theta, what I said, is the same bound, same number of times. Got it? Big O, minimum number of times. Big omega, maximum number of times. Big theta, same number of times. And in this case, I have represented C of 1 belongs to big theta of n. Why big theta? Why not big O or big omega? Because in this solution, comparison should execute n minus 1 times exactly, not even 1 less than n minus 1 or 1 greater than n minus 1. Clear? So comparison is going to execute n minus 1 times exactly, that is same as n minus 1 times. Not even 1 less than n minus 1 or 1 greater than n minus 1 times. So we are going to make use big theta. Clear? Why we are means we in previous session we studied right according from previous session you will come to the n minus 1 belongs to big theta of n. So this is about analysis. Clear? So now let me discuss one more problem. Okay. So design an algorithm for the element uniqueness problem. That is the problem of determining whether all the elements in a given array are distinct. Analyze the efficiency of this algorithm. Okay, what problem statement says means you are given an array with n elements. Okay. Now you need to check in your array whether all n elements are unique. Means you will be given an array with n elements. You need to identify whether all n elements are unique. I mean, there are no repeated elements. If all elements are unique, you need to return true. If at least one element is repeated, okay, you need to conclude false. I think got the problem statement right. Means you will be given an array with n elements. You will be given an array with n elements. You need to check whether all n elements are unique. If all n elements are unique, return true. Say true. If at least one element is repeated, say false. Okay, coming to solution, what you will do means, we need to list all possible direct solution. I tell you, means what I need to say. Here n elements there or there, so we need to list all possible paths, all possible paths from this n elements. Okay, and the any one pair contains same elements, okay, will return false. Or to be more clear, okay, to be easier, let me tell. I'll take the first element. I'll compare first element with second. If first element when I compared with the second match occurred, okay, match occurred, then I mean first element is repeated twice. Let me return false. Suppose the first element mismatched with second, let me compare first element with third element. If the first element matches with the third, first element is repeated. So let me return false. If mismatch, let me compare first element with the fourth element. Let me repeat this process. Now let me assume the first element didn't match with any of the other elements. So now what we'll do, let me compare second with other elements. Second element with other elements. Okay. Now, in this case, I won't compare second with the first because it's already comparison has been done in the previous parts. Now I'll compare second with the third. If a match occurs, let me return false. If mismatch, let me compare second with fourth. Repeat this. So whenever a match occurs, I'm returning false. Okay. So it means when the return value of this algorithm is false, it means array is not unique. Array is not unique. Okay. All possible comparisons have been done. Okay. In none of the comparisons match occurred. So it means array is unique. Got it? So if you just analyze, if you make use of your mathematical induction skill, okay, you will come to know there will be n into n minus 1 by 2 comparisons that I'll analyze. Okay, so we'll look at that. So the same thing, what the solution I said here theoretically, it's redesigned as an algorithm. See, for I equals 0 to n minus 2. Okay, I need to I equal to 0 means first I is pointing to first element. Then j should point towards second element to last element. So j is I plus. Got it. Whenever I say the ith element when matched with the second element, what I said, return false. Okay, if not, proceed this comparisons. Okay, with the subsequent case. Clear. So finally, when all possible comparisons have been done, when none of the comparison match occurred, I need to return true. This is what. So now let me come to the analysis part. Okay. So now this can anyone now everyone according to steps and general plan. You know, right? The first step is I need to identify the size of the problem. It's very clear, right? Size of the problem in this case is n. And what about the basic operation here? The basic operation in this case is what? Again, comparison. That is A of I equal to A of Z. Okay. Second step is clear. What about third step? Now, whether this comparison depends only on n or else it depends on any other parameters? Of course, in this case, comparison depends not only on n, but it also depends on elements of an array. For example, let me say, if the first two elements of an array are repeated, okay, then comparison is going to exist only one time. Because in the first comparison itself, I find a match and I'll return false. Clear? This is the best case. Okay. So in best case, element uniqueness problem, basic operation count exists one time. In the worst case, the repeated elements might be the last two elements in an array, or the all elements in an array are unique. Okay, in worst case, the repeated elements are the last two elements of an array. Okay, all the elements in an array are unique. In that case, what I'll do, I'll do all possible comparisons. All possible comparisons. Okay, and that comparison will find how many that count of the comparisons. So how many times that comparison is going to execute in worst case, we will identify by setting up summation. Okay, setting up summation. Now, what is summation? Okay, well, now I will look at this. First, in the best, okay, 1 second. For the best case scenario, in best case, basic operation count is what? One time, one. Because in the first comparison, it will match of us. In the worst case, repeated elements are lost to, or all elements are unique. In that case, all possible comparisons. So summation here is summation for j equals I plus 1 to n minus 1 comparison. Okay, and this inner loop that is for j is going to execute for each I. Got it? So I mean to say, I repeat, comparison a of I equal to a of j is going to execute one time for each of the j value I plus 1 to n minus 1. Got it? And this inner loop for j is going to execute for each of the I values 0 to n minus 2. Yeah. So this in the form of summation, we are going to represent like this. C at the last. C worst of n equals summation I equal to 0 n minus 2. Summation j equals I plus 1 to n minus 1. Now, think of again mathematical induction. Solve this. On solving, you're going to get C worst of n is n into n minus 1 by 2. Got it? So C worst of n, basic operation count in worst cases, n into n minus 1 by 2. And what is this n into n minus 1 by 2? N square minus n by 2. And what type of function is n square minus n by 2? It's a quadratic. So this basic operation count C worst of n, I say it belongs to big theta of n square. And why again big theta? Because in worst case, all n minus all possible